Hello everybody, in this video we're going to be going over partial edge control, okay? Now before we get to that, I'd like you guys to let me know how this background looks. So, should I continue using this or switch back to my other one? Let me know in the comments. Or if you want me to use something else for my background, let me know. Okay, so anyway, for partial edge control, if you don't know what that is, it's basically where you insert your last F2L pair differently to give you a better OLL case. The worst OLL cases are dot OLLs where we have no edges oriented. And the best ones are ones where we have a cross OLL, which is where all the edges are oriented. So how do we use partial edge control, okay? So basically what we're going to do is we're going to make your OLL better the best we can, okay? So this is something that's called EO, okay? So that it's called edge orientation, okay? So that's what we're going to be looking at here, okay? Now, there's a lot of different ways you can do it, okay? So you can learn all the different cases for this, okay? However, we're not going to go through all that here, okay? If you guys want to learn that, that's up to you, okay? But I don't really know if it's worth learning all those cases just to get this OLL because there are, believe it or not, some OLLs with just two edges oriented that are surprisingly faster than this one. This OLL, for example, here has two edges oriented, but it's only 6 moves to solve it, okay? So it's not really a lot. So all you really gotta do is avoid the dot OLL cases and force a cross OLL case if possible. So we have the last F2L pair, but you can quickly notice that there are no edges oriented properly, okay? So what we have to do is we have to insert this differently. So if you insert it normally, you get a dot OLL case. If you insert it with a sledgehammer, you'll get a better case. And if you don't know what a sledgehammer is, it's R prime, F, R, F prime. Okay, and as you can see, that gave us a much better OLL case. This can also be used if these two edges right here are opposite from this. So if the edge that's kind of trapped by the pair is not oriented, but the rest are, you can insert it, and then you get a cross OLL case. For the rest of the cases, it's better to just insert it normally, or if you have an algorithm, you can insert it using that, okay? I won't go into that in this video, but that's what you can do. Taking this a step further, we can also look at the corner orientation and we can base on that and figure out the best way to insert this, okay? So we can insert with a sledgehammer, which gives us a pretty good OLL case, but inserting it normally will give us our 6-move case, which as we all know is much better. So there are 216 different cases for this, okay? And subtract 27 from that, and that will be basically for non-dot cases, okay? So I'll put the number right here, okay? So those are all the different cases you'd have to know, and what you can do is you can insert it using different insertions, okay? Like, for example, instead of inserting it like this, we can also insert it like this. So that's what we can do here, and we can force even better OLLs. So I'm not going to go into all the different examples for this application. I will leave that for you to figure out yourself, okay? Because it's pretty much self-taught, okay? You just need to judge which OLL is better if you find two of them that are relatively the same. It's all up to you, whichever one you feel more comfortable doing. But what do you do if you have this case right here where they are separated? Because you can't guarantee that you're always going to get it where it's paired up like this. And pairing it up like that, in my opinion, takes too much time just to do partial edge control. So this case here, only use it if you have a dot case, okay? You're going to want to do this algorithm. You're going to want to do R prime, D prime, big R, or small R, U prime, small r prime, D, R2, U, R prime. Alright, and as you can see, that solved all of the edges from that dot case. There are a couple other ways that you can insert this pair, but I'll leave that up to you to figure out. And just like with the other one, if you get a certain case, you can choose to insert it using that or this algorithm or the other one that I mentioned, okay? I'll put the other one in the description actually, because I don't actually know, but I will put it in the description if you guys want to check it out. But what do you do if the pair you're inserting doesn't form either one of those? It just stops like that, and you get a dot case. What do you do? Well, here's the answer for that, okay? You can use a different type of algorithm, so basically a different algorithm for that specific case if you run into that, okay? I'm not going to go through all the different examples. I will leave that up to you to figure out. So this case that I just showed you like this, another way you could insert it is doing this. It's basically using the beginner's method to pair this up, which gives us a much better OLL case, okay? And there's a lot of different ways you can do it. So that's only for the cases that do that, okay? And this case, by the way, it's only for the angle where the edge can be inserted correctly, okay? Like this angle, you automatically do it, okay? So that's just one thing to keep in mind for this. Only the angles where when you do your algorithm, it causes there not to be any one of those, okay? So once again, I won't go through all these. I will leave that up to you to figure out, okay? But if there is a case that I didn't mention here but you can't figure out, you can post it in the comments which case it is, and I might make a video on some of the cases. Okay, so please give me a setup algorithm so that I know which case it is, otherwise I might be a little bit confused. So thank you guys for watching. Hopefully this video was helpful for you guys, and using this will give you no reason to have to learn the .OLL cases, okay? If you know how to do this 100% of the time. So thank you guys for watching, and I'll see you guys on my next video.